Hello, everyone, and welcome on the My Open Source Experience podcast. Today, I have Brad Chamberlain with me, and I'm super excited because we will talk about the Chapel project. And it's not just a quote unquote regular open source project, it is, in fact, an open source programming language in the supercomputing space, which I am personally always super excited about. And when it comes to projects around programming languages, I'm a little less familiar with those. And we will talk about this project from the creation towards its journey to the High Performance Software Foundation, or if you're familiar with the space, HPSF, which the project joined recently. But before we go all into this, Brad, can you please introduce yourself a little bit to the audience? What is your background in tech and what do you do currently?
First, thanks very much for having me. My name is Brad Chamberlain. I'm a distinguished technologist at Hewlett-Packard Enterprise. And I'm a sort of a combination computer science researcher and computer programmer. I got my background, like a lot of kids in the 80s, programming VIC-20s and Commodore 64s in my parents' basement. These were very exciting to me, kind of electronic toy that you could make do whatever you wanted. And so I taught myself some programming there. In college, I continued that and majored in computer science. And then it was really in graduate school at the University of Washington that I got my current focus on supercomputing, so large-scale computers for doing massive computations, and specifically doing programming languages designed to make supercomputing easier than it is today.
So it sounds like that from the early days of teaching yourself how to code, you really got a passion for programming languages, like how to tell the computer what to do.
Yeah, for sure. I mean, I think the thing that was so mind-blowing about those early computers in the 80s was, again, the sort of flexibility that, up until then you could buy electronic games that would do one thing or, toys that would do certain things. But the notion that you could sit down at a computer and use one of these programming languages to have it do something that you wanted it to do, as you were thinking of it. I think one of the first things I did was with one of my friends in the neighborhood. We programmed it to play Mary Had a Little Lamb and to render the notes on the screen at the same time. And I'm sure we did it in a terrible way that I would kind of, wince at. But the fact that we could just sit down and like, let's see if we can do this and could make it do it was very kind of mind-blowing to me at that age. And then through college, I got exposed to different languages, and yeah, that sort of led to me to where I am today. To talk a little bit about my career path, so when I graduated from graduate school, I spent a year at a startup that was very educational, but also challenging. I then took a job at Cray about a year later, and that's where I was a software productivity lead. And then in 2019, Cray was acquired by Hewlett-Packard Enterprise, and so now I'm a Hewlett-Packard Enterprise employee. But yeah, the first job I had at Cray was that Cray had just started this government program. They were one of 5 companies to participate in this program sponsored by DARPA that was called the High Productivity Computing Systems Program. And the whole notion of this program was that as a nation and worldwide in the HPC community, we're very good at building larger and larger and faster computers, but we're not very good at making ones that are easier to use. And so the goal of this program was to focus not just on performance and scaling up performance, which is where supercomputing and HPC typically focus, but instead to look at, well, how can we make these systems easier to program? And so when I was hired as a software productivity lead, basically my job was to figure out, like, well, in software, what kinds of things could we do to make supercomputing users more productive? And so again, that was my initial role when I joined Cray.
So it's kind of helping people to be able to use the software easier and better. So it's not about making the software, let's say, more productive, but the people who are trying to use and interact with it, or kind of a little bit of both.
I would say a little bit of both. I'm realizing I use the acronym HPC, which for me stands for High Performance Computing. So again, supercomputers, large computers that can do lots of operations in parallel and solve some of the world's most challenging problems. And I would say our community tends to be very focused on, again, making bigger and bigger systems and faster systems. But often the software side of it, the user side of it, is kind of left in the dust. Sometimes I equate it to being a race car driver, where, if you're a race car driver, not that I know much about it, my assumption is that it's all about how fast can you go? Can you win the race? And probably not as much about the driver's comfort and, experience in the car and things like that. And I think the HPC field is a little bit like that as well. We're very focused on solving these problems, but sometimes the practicalities of using the system, programming it, using the tools on it are left in the dust. And so as a company, we were challenged, and as the software productivity lead, I was challenged with what kinds of things could we do in software, either making existing software easier to use or producing new software that would make these HPC systems easier to use, more productive, more resilient to failures. Basically just anything that would kind of bother a user or slow them down. How can we iron out those bumps, essentially?
So you kind of came a little bit of full circle from your childhood experience of that programming with your friend, and maybe the program that you wrote wasn't the most efficient, the nicest way to code that particular functionality, all the way towards trying to figure out how to make supercomputers a nicer experience to use. That's pretty cool.
It's a crazy difference in scale. The VIC-20 I mentioned had, if I remember correctly, 3.5 kilobytes of memory, which a photograph today that you take on your smartphone would probably be bigger than that, right? And these supercomputers are just massive. Even in my career, when I was a graduate student, when I finished my PhD, I was really proud because I had done some runs that used 256 processors or 256 compute nodes, which at that time was a pretty big number, I think, particularly for a student like myself. And now I've had members of my team run on over 8,000 nodes and over 1 million processor cores. And those are just numbers that I couldn't have conceived of even as a graduate student, let alone as a teenager in my parents' basement. So yeah, the scales of these systems are mind-blowing and seemingly getting bigger and faster all the time.
I mean, those numbers, to me, who's not working in the supercomputing space, they are still pretty big.
They're the kinds of numbers where, sometimes people will give you these numbers like, we sorted 256 terabytes of data, and you're like, I can't even conceive of what that means exactly, right? It's just hard for us to get a grasp on, I think, as mere humans.
That is true. However, once you run a podcast and you keep running out of external hard drives because 2 terabytes don't seem to be enough for anything anymore, then you start to grasp it. Although after that experience, I really don't understand how all the world's data fit into any device, or the collection of devices that we have on this planet, because that's just insane.
Right.
Insanely enormous amount of data.